So I talked about my all sky cam. Here's the camera that sits over my back garden in Bath. So you can see the aeroplanes flying over regularly, and occasionally the International Space Station. But you can see this was taken on a windy night because everything's moving around. But you get to see some of the winter constellations coming up. We've got Taurus, the Hyades and the Pleiades here. And if we wait long enough, you'll get down here, we've got Mars and Venus will be coming up shortly before. So there's loads to see. And this is only a couple of nights ago. Milky Way, even though we've got Bortle 5 skies, sort of suburban, quite light polluted skies, you still get to see all these things. And that's just straight from the back garden. So it's always worth a visit out to see how the garden's going behind you. Hopefully you haven't got any nearby streetlights. Bath Astronomers, we're a friendly group, so please say hello opportunities. If you see any of these faces on the street, stay 2 meters away, but shout hello. We haven't really got a secret handshake or anything, which we wouldn't be allowed, but the people helping out with all the organizing, we've got Abby, Chris, Dennis, Jonathan, and myself. We do most of the organizing for all the activities that go on, and we've been busy at it for the last 9-10 months, so we're up for re-election in November. But if you'd like to get involved, the more the merrier. We haven't got a limit, and Dennis is stepping down as secretary, so if you're interested in that role, please let us know. And in the November one, before the talk, we'll have a quick show of hands to see who'd like to take on roles or who'd just like to be an ordinary member, just to chuck in some ideas, sort of find out more about how we sort of run things and how we organize things, but the more the merrier. So I'm going to quickly, hopefully limit myself to 10 minutes, going through these 3 topics, just on what's been happening over the summer, what's coming up in terms of events, and what's up in the sky. So hopefully I won't go on too long. The big news for us is we officially became a society, or back in November last year. We'd been an ad hoc sort of group of people up until then, under the wing of the Herschel Society. But we set ourselves a goal of having 15 members when we set ourselves up formally, and we've hit 33. So we won't aim for 15 by the end of our first year. Well, we're not there yet, and we've got to 33. So thank you very much. And the more the merrier. So if you've got friends or other people that might have an interest in astronomy, please let us know, and we'll see if we can help out, and they can join and sort of get the most of looking up. You don't have to be a deep sky observer. You can just enjoy sitting on the park bench and looking up and just wanting to know what that particular star is. Any kind of member is a good member. So what have we got planned for our year ahead? We booked all of our talks before COVID came around, and so they're pretty much going to shift over until the situation changes to all be online. So we'll be Zooming for quite a while probably to come. But here's what we've got. So if you read BBC Sky at night in the binocular section, you'll know Steve Tonkin's work. So he's talking to us on the 28th of October. And we've got Bud Martin, quite suitably with what's happening with Mars at the moment, talking about a life on Mars. We're inserting some special events coming up. So on the 16th of December, we're going to have a bit of a social evening. We hadn't actually planned for that, but at the last team organizing session, we sort of said, hey, let's do something before Christmas and try and brighten things up. And if you know Nick Howes, he's going to brighten up our Januaries, probably or hopefully not with too many expletives. It'll be one which we can't directly push out to YouTube, etc. Because Nick is, I love him, he's very opinionated and he really says what he feels, and he's going to be talking about satellites and all the space debris up there. And then sort of further, all talks going through, taking us through to June. But hey, we set this up. This program is intended to be a sit down, going to the Herschel Museum program. We're online, so if you've got any ideas, if you think we should be doing a little bit more different types of talks and things, then just let us know, and we'll see what we can organise. And if you volunteer to be part of the organising committee in November, then you can be directly involved. We've taken the decision as a group that when we normally go out doing public stargazing this time of year, we're holding off on that. We can do it in a COVID secure way, but it kind of does increase people's risk, and it's kind of an unnecessary risk to increase. So for general members of the public, we're not going to be doing stargazing sessions, but we are going to be able to support more controlled sessions, bubble sessions. So where someone's pre-booked to be at something. So an example of that is where we're helping out the Herschel Museum of Astronomy with their events of an evening where people are pre-booked. Up to 6 people come into the museum. They have a special hour-and-a-half session. They leave the museum, and then a little while later we get the next group in. So we feel that's a manageable thing, and that's the way we'll go ahead. In terms of our members, though, we'll still organise members' evenings where you bring your own kit, you use your own kit, and someone could be a few meters away, perhaps giving you a little bit of guidance, but not sharing anything. So we'll still be doing all of those. So don't worry too much, but that's probably the most prudent way of moving forward. It means we'll have to be a bit creative for things like World Space Week, which starts next week on the 4th of October through to the 10th of October. And that might be, if we get a chance, to bolt a camera onto the back of someone's telescope and just broadcast that on our Facebook page, that kind of thing. Let's see what we can do to try and get involved. And perhaps we'll do something a little more organized on the National Astronomy Week, which is from the 14th to the 22nd of November. I did mention those Herschel events, and so if I just show you what they are. There you go. So there's 4 Herschel events, including a Halloween night, which should be quite entertaining. I think Charles has volunteered to help out on those. So he's done sterling work over the summer with Jonathan on the solar observing sessions at the Herschel Museum. So are you going to be dressing up? Are you going for the Halloween one, Charles? You've probably been all muted, so that's okay. I can imagine that you'll be wearing a witch's hat and all greened out, Charles, so fingers crossed. Otherwise, they'll make me do it, which I'm not looking forward to. Right, so we're up for as much information or sort of ideas as you can possibly throw into the pot. So we've got a little web page there, just I think. So it's our normal website, but I think. And if you just want to throw in ideas, you can do them anonymously, or you can put your name down, whatever you want to do. But if you've got some ideas of things that we should be doing, things we do differently, just pop along there and chuck your ideas in, and they'll go to the organising team, and we'll see what we can do to actually make them come true. And if you do put your name down, we'll probably ask if you want to be involved in doing it as well. You don't have to say yes, you can just put your ideas in, but let's see if we can get a bit more two-way stuff going and give you what you want from an astronomy society. So should we move into what's happening this month? Well, it's going to be full moon. That's tomorrow. October's graced with 2 full moons. I think it's officially the harvest moon tomorrow, but I try not to use it. It's a full moon. It's a full moon. I'm going to call it a full moon. And as we go on through the month, on the 3rd of October, there's some interesting stuff happening in the morning. Venus is going to whiz past the bright star Regulus in Leo. So that's the kind of view that you'll probably get through a telescope. The actual closest point you're going to miss, it happens before Venus and Regulus rise, but about 4 a.m. in the morning on the 3rd, you'd be able to see them very close together in the sky. And just generally, as we're looking out of an evening in October, you'll be seeing Mars coming up in the night sky. And then chased behind it there's Uranus as well. And we start getting to see some of the winter constellations, as I mentioned before, and some good clusters like the Pleiades and the Hyades down here. and Betelgeuse, which I think as of last few weeks, it dimmed in December down to about in January, and then on the way through to January, everyone thought it might go bang, and now it rose back to normal brightness. It started dimming a little bit again, so it's having a bit of fun in the constellation of Orion here. But this is winter coming. We're still autumn, so don't worry too much. So you don't have to get out your long johns quite yet. But if you stay up late, so just after midnight, you're starting to see all these wonderful winter constellations as well. You probably haven't missed it, but Mars is really the big thing in the sky, and it reaches its closest point to the Earth on the 6th of October. And this is a series of images taken, which takes it over a period of a month or so. And as it gets closer, of course, it's getting bigger, and you get to see more and more detail on the screen. Now, the Roger Hutchinson, who took this image, he's just using sort of pretty medium to high-end kit, but it's all the stuff you can buy if you're so inclined from First Light Optics. Other suppliers are available, but lots of people in the UK are currently taking snaps like this. So there's lots of exciting stuff to see. And you even notice, if you look at the southern polar ice cap, you'll see it's actually changed size as it gets closer and closer to the sun, and both to Earth as well. So that's the closest point. And on the 13th, it will hit, I think it's a slide on time, but on the 13th, that's when the Earth travels between Mars and the sun. So the next 2 weeks, that very bright star in the sky, that's a planet, and it's Mars. It's a lovely salmon pink hue, reddish hue. So have a look. If you can get to a telescope, well worth it. There's other things in the sky. So we've got meteor showers. So one of the first is the Draconids, which is between the 6th and the 10th of October. It can be a bit of a boring show, sort of like maybe 1 or 2 meteors per hour, slow coach, but on some years it's boosted up to 300, maybe even 1,000. So if you think it's one in a 25-year kind of thing, sort of in terms of how lucky you're feeling, then maybe it's worth popping out to see if we've got some activity on the Draconids. Mars, we've already mentioned. So here's one of Damien Peach's good shots, which shows the area of Olympus Mons coming around up here. So you can see a load of detail. So it's worth having a go. The Orionids around the 20th of October. So there's then the full hour rate. It's a bit more reliable. It's 25 or so once it gets up high. So you'd have to wait in the early hours of the morning to see that. And we've also got the Southern Taurids, which is a much slower shower around about the 10th of October. But still worth going out to see. And at the end of the month, we've got the opposition of Uranus. So the Earth will travel between Uranus and the Sun, and that will be the biggest and brightest you'll be able to see Uranus this year. So it's in theory visible to the naked eye. You can find it with a finder chart and some binoculars, or if you've got one of those wonderful go-to telescopes, just hit a button and you'll see a greeny bluish blob in your eyepiece. And the thing that rounds off the month is that second moon. I've coloured this blue because some people call it a blue moon. It isn't. So enjoy. You get 2 full moons this year, also this October. So if you're a deep sky astroimager, you can go, but you've always got the planets to look at, even if the moon is full. So if it is raining, there's loads of stuff out there now. So whether it's listening to podcasts by Dr. Becky, Awesome Astronomers, SPA website, that's Pop Astro, there's Reach Out and Touch the Sky, there's loads of stuff. So there's no real excuse. If you need your astro fix, they're available from YouTube or from your local podcast supplier. So get out there and sort of listen. The Marlborough Dark Skies Festival, which was due to be happening, that that's effectively gone online, and so this Saturday they're taking over the airwaves to sort of have their festival and a series of talks. So it's worth visiting that particular URL and seeing what they've got on. There's various talks. Mary McIntyre's giving talks. I think lots of other people are. So another way to get a great fix for your Astro. And if you can manage to pop out to Exmoor, Exmoor are running their Dark Skies Festival for real. They're doing it COVID secure. So it's worth popping along to their website to see if you want to or can attend some of their things. So they've got talks going on, much reduced size, everything pre-booked, and they've got walks as well. So if you want to see the beauties of Exmoor and you do have your long johns on, then that's well worth popping along to see what's going on. Now, I did promise an update to Roger. So here we've got Chris as my model, showing off the, looking through the 7-inch refractor. It's 9 foot long that we found at Monkton Combe School, and we've got an agreement with the school to rebuild it, set it up as a community observatory. So we discovered some lead paint on it, so that's kind of stalled us, but we're mostly sealing that in, finishing the work around that, cleaning up any paint fragments, and then we can get on a pace to fit it out. But part of the fit out has already happened. We've got bench seats going in, which gives us storage and things. All the walls have been painted, floors been painted, and we've done the first attempt at lining the optics after they came back from being cleaned. We've still got quite a bit of work to do there, but we'll see how that comes along. It's quite hard working in a COVID secure manner, sort of getting lots of people in to sort it out. So that's one of the reasons why it's slow, and the lead paint has slowed us down a bit more. But yes, we are still making progress, still got lots of ideas. I think I have to send them some ideas for the junior school, because we've given the juniors classes the task of decorating the bench seat we've got there. I think we'd use something called decoupage. I'm not an artist myself, but I think that's the idea, is to cut up old copies of the Sky at Night magazine and glue them onto the seat. So you'll be sitting on galaxies and planet images and things like that. So making it a bit of fun and less austere. So the idea is to make it sort of an observatory that will have not just this big telescope, but other sort of telescopes that can be taken outside and used. So things are moving on. If it wasn't for COVID, we'd probably be a bit further on. If you want to volunteer and help out, just drop me a line and we'll see what we can do to whether it's a little bit of painting or actually we've got display boards to put up and things. There's loads of stuff that will need to be done. Okay. And I've almost made it. Now, I stole this from someone. Whose image did I steal here? This is Mark's image. I stole it from his website, Refreshing Views, and he's taken this recently of Mars. So we did have Damien Peaches. I think that's almost rivaling Damien Peaches. So well done, Mark.
Oh, thank you very much. I'm a bit honoured if you say that. You must be something in the water.
So we've invited Mark Radice to come and talk to us tonight. He's a very, very active observer. I think you sort of set yourself up as a bit of a comet lover. And when you first sent me your bio, Mark, you said you were desperate for a new good comet. And this was before Neowise. So hopefully Neowise was good enough. Maybe not a Hale-Bopp, but good enough to keep.
It was pretty good, wasn't it?
Yeah. So you've got your own observatory in Salisbury, I understand.
That's right.
Yeah. And what's your main instrument is a Celestron 11-inch SCT?
C11 I bought second hand from one of the club members in Amesbury, and I've got a pair of binoculars as well. So
excellent. Well, I'll hand over to you, Mark. I'll let you take over the show.
Okay, thank you.
You can take us through observing the planets.
Right, let's just get this all ready.
I'll stop my share.
So bear with me as I just click everything around.
That's okay. If anyone had any questions from what I did, now's a chance to just unmute yourself, hopefully. Hopefully you'll be allowed to do that and ask away.
So I am now trying to find the share screen button. There it is. And we want to share that one. So that should be coming through now. Could you confirm you can
Excellent.
see that?
I can see that.
Yep, observing the planets. Right, so let me just hide that. So what I'm going to give you a talk on is why I go about and enjoy observing the planets. I'm going to describe my own techniques, and I'll try to explain how I go about doing things the way I do things, and I'll include some of the highlights I've enjoyed out there in the dark, in the cold, at night. So first of all, I want to say thank you also for having me along. One of the strange things about giving a talk on Zoom is, of course, I'm sitting in an empty room. I'm in my dining room at the moment, and I imagine you've probably all now logged off and gone off to the pub or gone off for a drink or to watch Coronation Street or something. So please don't do that. I imagine you're all on the edge of your seats. And as I'm not driving tonight, I'm going to carry on having my gin and tonic. So these are, with the exception of one photograph in the talk, so I beg your pardon, 2 photographs in your talk. These are my own photos throughout. And as I said, I'll try and talk through the techniques and the approaches I use to do my astronomy. Now, before we start, I'm going to have to assume that you know what a planet is. And then the premise that you never make an assumption, I'll now have to explain what a planet is. So the definition, the International Astronomical Union definition of a planet is it's got to be a spherical body. It's got to have enough gravity to be round. So that rules out the asteroids and the comets, the irregular shaped bodies. It's got to orbit the sun, so that obviously rules out the sun. It's got to orbit the sun, so that also rules out the moons. And the clincher is that it swept its orbit clear of objects. So the dwarf planets such as Ceres are not, because they're not a planet, because they orbit in the asteroid belt, and Pluto isn't, because it orbits in the Kuiper belt. So you'll also notice on the screen I've got in front of you then, there is a bar of planets across the screen. And these are the pictures I took when we went on a club trip. The Basingstoke Astronomical Society, we had a club trip out to Tenerife in 2018. And I imaged every planet in the solar system in one night. And the trip itself is a talk in its own right, and it is a rather wonderful place to observe, particularly with the weather we've got here in Salisbury tonight. So in addition to being on a mountain at 28 degrees north, so all the stuff that interesting stuff in the sort of centre of the Milky Way, which you can't really see from the UK, we're nice and high in the sky. We had access to this sort of outdoor observing area at the observatory as well. And we also had things like, you know, there was a loo and a kettle and a fridge, so we could store our stuff during the day and come back along in the night. So in addition to observing all the moons and the planets that you can see on the bottom there, we also got the Earth's moon as well. We saw Vesta and Ceres. One of the club members also, together we found and then imaged Pluto. So it was a real solar system tour. And I think when we finished, it was 28 solar system objects we'd observed in one night. So we didn't image them in this order. This is the order they are from the sun. So starting on the left, you've got little Mercury and Venus and Mars. Venus, of course, been in the news with this discovery of phosphine in the atmosphere, one of the biomarker gases. And these are rocky planets. Obviously, the Earth's one of those as well. So the 3 on the left are the rocky inner worlds, the terrestrial planets. There's then a bit of a gap as we jump over the asteroid belt, and you've got Jupiter and Saturn. Jupiter's a very dynamic planet, lots of storms, etc. on its surface. And Saturn here with its beautiful rings, and these are gas giants. Their atmospheres are made up of gases. Their bodies are made up of gases. They've got no rocky surfaces. It's gas all the way down until you hit the core. You then jump out again, and you've got Uranus and Neptune. These are right out on the edge of the solar system here. these are called ice giants because their atmospheres are so cold. They're actually not made up of gases anymore. We're starting to turn into ice particles as well. So you go all the way from baking hot Mercury orbiting right in close to the sun, all the way out to Neptune, right out at the depths of the solar system. And each planet has its own characteristics, its own environment, its own feel. So it was a great fun trip being able to photograph all those in one night. And I say it's an awesome place to observe. You've got all these wonderful, professional university. ESA has facilities there, tracking whatever it is. So I say this isn't my photograph. This is taken by one of the club members, but at least I'm in it, so I suppose I can claim some of that. And the hardest thing about that was trying to keep myself still for 30 seconds while he took the picture to capture the stars in the background. So this was the view at sunset, and of course you can't observe all the planets in the solar system and then miss the Earth. And this mountain on the left-hand side, just poking up there, is Mount Teide, which is, I didn't realize this, is actually the highest mountain in Spain, off the coast of North Africa. So nice and high. And then you have the crescent moon, Venus, Regulus, and just disappearing down into the sunset was Mercury. So beautiful spot, really pleasant. So I started out observing, it seems an awfully long time ago now, in 1996, which I can't believe has been so long. And I was working in Canada at a boarding school before I went to university, and they had a talk from a visiting astronomer who said, we're really lucky because these bright comets that we see gracing the sky, and you mentioned Neowise earlier, that there hadn't been a bright comet for some decades. And like buses, there were going to be two coming along at the same time. And this first one was Comet Hyakutake, which came across the sky in March 1996. And I borrowed a pair of binoculars from someone. I'd always been interested in astronomy, but hadn't really done much sort of practical observing. But I borrowed this pair of binoculars and went outside, and I found the plough, and I worked out how to find this comet. And it took me several attempts to do it, but I actually managed to sketch the comet in my notebook. And it just shows you this is in March, 25th of March 96. But a few days before that, unfortunately, a major snowstorm has struck, and that's the joys of observing in Canada. So when people say it was a cold night last night, it was at least -5 or -10. I can assure you, observing in Canada in the middle of winter is a lot colder. And for years, I've been thinking, wouldn't it be wonderful to see a really nice bright comet come past again, because now I know how to use, I've upgraded now from a pair of handheld binoculars. I've got a camera. So it was a real pleasure to enjoy Neowise earlier this year. And that was the view I had. And I can't remember which, one of the July mornings, we had this beautiful noctilucent cloud display. And it was absolutely wonderful. So I got up at about 2 in the morning. Oh, it was horrendous. I hate 2 o'clock in the morning alarm clocks. But of course, with sunrise being at about sort of 3:30, I had to get up at 2. And I went outside sort of bleary-eyed and thought, right, now where's this comet? It's going to be low down. I thought, oh my goodness me, it's this brilliant bright comet stretching across the sky. So I went and woke up my poor wife, who rather, after a bit of a thorough and frank exchange of her views, she poked her head out and said, oh wow, that was really amazing. So we quite enjoyed that. And then I said, right, I'm going to walk up to one of the fields near the house, get away from the village street lights. And as I was walking down the road, a police car went past and stopped me and asked me what I was doing, wandering around the village at this time of the morning. What on earth was, sort of my camera tripod in my hand, and asked me what on earth I was doing. So I didn't know that photographing comets at sort of 3 in the morning was a sort of police matter, but they were obviously doing their jobs. So, the first time I've ever been stopped by the police going to see this comet. So one to tell the children about one day. Right, so this is my observatory in the garden. And you'll see that there. I must highlight this is a time lapse. This is not me at real time. This is sped up. You can see the sky starting to get dark now. So I observed near Salisbury, and inside the observatory is a Celestron C11, and this photograph was taken earlier this year when I was imaging Venus, and you can see Venus down there on the camera screen down on the desk. And I must admit, having an observatory has really changed how I go about doing astronomy. So in the olden days, before the observatory was built, I'd have to take the telescope outside, go back in, get the mount, set the mount up, line it up, put the tube on top of the mount, run power, put counterweights on, and then of course at whatever it was, midnight, 1, 2 in the morning, whatever, you have to do it in reverse. Take the tube back in, take the mount in, take the counterweights, and it became a real faff. So having an observatory, just having everything set up, all my kit, all my notes, all my charts, having power already in place, it absolutely makes astronomy such a pleasant experience. And of course, with lockdown, I've got a little warm room alongside it. So that's become my home office, as we've all been told to work from home over the past few months. So it's been an absolute godsend. So from a family point of view. But the kids actually, they wanted a hot tub in here. They thought it'd be brilliant being able to have a hot tub and roll the roof back and be able to see the stars. They had this little room next door to, get changed in. So I put my foot down, and it's staying as an observatory. Right, a few years ago, I was working in Milton Keynes, which was an experience coming from Salisbury to go out to Milton Keynes. But while I was up there, rather than carry the big telescope back and forth, I bought a second-hand Maxutov, this telescope here. And this became the telescope I left up there, just put on this little tracking mount. And the light pollution in Milton Keynes is so bad. You've got Milton Keynes itself, which is obviously a big town. You've got Bedford just up the road in Northampton. So the light pollution around there is really bad. So all you can really see is the moon and planets. But I bought this telescope for £250. We met in the Asda car park to hand over and to check telescope over, and then went for a coffee inside Asda. And what I'm trying to do is, rather than talk about the results I can get with the big telescope, I'm going to talk about the results I did for a number of years with this little telescope, and say £250 I know is not a small amount of money, but it is relatively cheap as telescopes go. And I say, a telescope I bought secondhand from a lady in Asda in Bedford. I've had so much fun with this little 6-inch telescope. It's absolutely been brilliant. And the other reason is simply that with the planets have been so low over the past few years, I haven't yet to really use the C11 that much in the observatory on the moon and the planets, which is one of the reasons why we went to Tenerife in 2018. But I've got some results now with Mars being nice and high, and we'll go through those later. So this little telescope really punches above its weight, I feel. So this video here is what I use to say why I enjoy observing the planets. And I've lost count of how many times I've looked at, the Pleiades or the Orion Nebula or the Veil Nebula, and they're absolutely beautiful, don't get me wrong, but they always look roughly the same. Whereas when you look at the moon, when you look at the planets, they're dynamic, they're ever changing. So we talked about features on Mars as Mars rotates. You've got stuff here on Jupiter. So Jupiter's rotating every 10 hours. I took these pictures in 2016, but you've got little Io appearing, and it casts its shadow onto the surface of Jupiter, and then quickly followed by Europa. And it's obviously relatively near opposition because the shadow lines up with the moon itself. And I'll say it before, but I bought that telescope secondhand from that lady in the Asda car park, and here I am in my garden, imaging the moon of Jupiter, casting its shadow onto the cloud tops of Jupiter. And also from a practical point of view, I find that finding the planets is relatively easy, because you don't need accurate go-to, you don't need to star hop. They're relatively bright. You just line up your crosshairs, and there they are. You can see them when you've got areas of light pollution, which I certainly found in Milton Keynes. And you don't need a big telescope. You don't need to accurately polar align. You can just get up and get cracking. So what I'll do then is I'll go through some of the images I've taken. We're going to have a little segue off to our nearest neighbor, which is the moon. Now, as I explained earlier, it's not a planet because it doesn't orbit the sun. And but I really enjoy looking at the moon. It's got this fantastic, being our closest neighbor, it's got this wonderful high resolution detail that one can pick out in a telescope or a pair of binoculars. And the Apollo astronauts called it this magnificent desolation. And I really enjoy looking at the moon because you get to see evidence of sort of planetary geology. You've got these craters which are leftover remnants of this sort of heavy impact bombardment. You've got lava floodplains, you've got geological faults in the crust, and you can all see this through the telescopes. But I want you to imagine that you're standing outside looking at the crescent moon like that, and the view one has with the naked eye of the moon is broadly equivalent to the telescopic view of the planets. So the lunar details you get to see in say even a pair of binoculars are actually better than what a typical scope will reveal, say on Mars. So remember that. So when you're looking at the moon with your eyes, that's roughly how big Jupiter or Mars looks through with the telescope. And certainly when you put a pair of binoculars or a telescope onto the moon, you're revealing far, far smaller details than you can ever see on the planets. So that naked eye comparison of this is roughly how big, say, Mars looks in the eyepiece is a good way of imagining it. And we'll go through some of those pictures in due course. And there really is so much fascinating detail to me on the moon. I hope these pictures are coming through on Zoom okay, because they starting to look a bit grainy on my screen, so I hope they're still coming through. This is the northeast corner of Mare Crisium, up in the top right-hand corner as you look at the moon. And you've got this wonderful impact basin. You get these mountains left over from when whatever formed Mare Crisium gouged out this huge crater, and this ring of mountains around the outside. And I love this little mountain here casting a shadow across the surface. It doesn't have a name, or at least it doesn't have a name in my lunar atlas. And then, of course, in time came on, the impact basin filled up with lava, so you get to see this planetary geology firsthand. I did hear a joke. My children always telling us bad jokes, and they did say that the Apollo astronauts, when they were on the moon, they said, the food is great in this restaurant, but no atmosphere. So, if you're going to have dinner on the moon, no atmosphere. And the other thing that I also think about when I look at the moon is if we were to see a rocky planet, say if you look at Mercury, or if you look at, where they're discovering exoplanets around other stars, is that if there was a small rocky planet near whatever star it is, it's probably going to look something like the moon. It's going to be heavily cratered. It's going to have lava floodplains. So when you're looking at the moon, it does actually have you can actually see this geology firsthand that's representative of other bodies as well. But let's leave the moon there, and we're going to have a look at this picture here, which is one I took a few years ago. And when I was looking, I thought, oh, hello, there's a bright star alongside the moon. And I thought, good Lord, that's not a star, that's Saturn. And I had to explain when I was showing this to the kids, I was saying, don't worry, this isn't they're not going to crash into each other. It's just a line of sight effect. Saturn is obviously much, much further away. But the point I'm having this picture here is to show the relative angular size there. So there's Saturn, absolutely tiny, and it's actually smaller than a lot of these principal craters that we can see here along the Terminator. And this is the thing we have about us looking at the planets, is that the objects we're looking at are really, really, really small. They're bright, but much smaller. So we'll bear that in mind. And here is the picture that I've nicked off the internet. And that shows you the relative size. This was an APOD, an astronomy picture of the day, published the other day. And this compares again the size of the moon to the Andromeda galaxy. And it's not really fair because the Andromeda galaxy is a pretty big object, sort of six degrees across or thereabouts. And it's much, much bigger than many other deep sky objects. But just looking at that, you remember how big Saturn was compared to the lunar craters. So Saturn on this scale would just be just a pixel or two in diameter. So just bear that in mind. So when we observe the planets, we're going to have to use high magnification to reveal those tiny details. And here's a picture I took earlier this year which was an occultation. So the moon is, of course, as it goes around the Earth every 28 days, occasionally goes in front of stars and blocks them off. And this was, you can see these little 4 dots here. This is Mars back in February. And the moon slowly went across, and just see it there, just blanks it off. So what I've done is I've stacked a few pictures I've taken. So it's really, it looks like this dot's moving towards the moon, but it's actually the moon moving the other way. So that was quite early in the morning, about 6 in the morning in February this year. And again, you can see how much bigger the moon is than Mars in this case. And it was absolutely terrible, you know, in February, 6 in the morning, under these palm trees in your t-shirt and shorts, you know, looking at sights in the sky like this. This is at the Winter Star Party, which I go to every few years when finances and leave and family commitments allow. So you can see there, observing under palm trees in February is a rather nice way to start the sort of the astronomical season. And this brings me on to my first recommendation for planetary observing, which is you don't need to have an observatory with a big telescope and a tracking mount. You can do some planetary observing just with a pair of binoculars. I've taken those pictures there, and you see, and that's just with one of these sort of smartphone mounts clamped over the eyepiece. And those were some of the pictures that I took of Jupiter rising early in the morning. And literally that is with an iPhone held up to the eyepiece. And you can see that. Oh. Can we have a mute there? So you can see here the moons of Jupiter visible through the binoculars and captured just with an iPhone, you know, just out of my pocket. So you don't need to have a big telescope to catch details on the planets. You can do it with a pair of binoculars and a camera. And a few years ago, in 2006 now, we had a really good spell at sort of June and July where the weather was pretty good for several weeks. And this is just with my handheld binoculars. I was going, our neighbours had a fence between our garden and their garden, a 6-foot high fence. And it was at just the right height. I could put my binoculars on the fence. Jupiter was quite low at that time. And I used to go out there and have a look at it, sort of, what's that, this 10, 11 o'clock at night. And I would look at Jupiter, and you can see the moons alongside. And I would estimate how many Jupiter diameters it was between the moons. And then when I did my sketch, kept right up on my notebook, I would then put this out. And you can see, particularly down here where we had a good spell, this is Callisto, which is the outermost moon of Jupiter, in its orbit as I went out every few nights, and then it goes back in a few days later. So you know those graphs you get in the Centre of Astronomy Now or Sky and Telescope, you can put these together. And this was just first out. I don't know what my neighbours thought as at about 10, 11 o'clock at night as this pair of binoculars suddenly appeared on the garden fence between us. Now my first daughter, Catherine Cat, was born in May 2006. So what you've actually got here is a coincidence of when it was clear, when I was awake at 9 or 10 o'clock at night, because often I wasn't, and yes, and when I had the energy to go outside. So when mum needed some milk or something fetched from downstairs, I thought, oh, it's just quickly clear, I'll quickly go and pop outside while the milk's warming up in the microwave, or get something out of the car, quickly make this sketch and then come back in. And she'd always say, why have you taken so long? And I said, oh no, just quickly doing this. And then it was a few years ago, 2017, 2018, and Jupiter's been very low, as I was saying earlier. It's been very low for a few years now, right down in the southern sky. And I was thinking, this reminds me of observing Jupiter all those summers ago, when the weather was nice, and be observing at 10 o'clock at night in the warm. And I thought, oh, of course, Jupiter orbits the sun every 12 years, and that was Cat's 12th birthday, which made it one Jupiter year. He'd gone all the way around the sky and was now back in the same part of the sky, low again, that I made these observations that I remembered all those years later. Now there's loads more visible with binoculars in the solar system apart from Jupiter. You've got asteroids, we can track comets, and so we talked about comet Neowise earlier. But it doesn't take long to realize that, you really do need a telescope to observe the planets in detail. And again, this is another point I want to make. I'm going to obviously have a lot of photographs in the talk. You don't need to have a camera to do planetary astronomy. Here's a pencil sketch I made a few years ago, and it shows you've got Syrtis Major, which is a feature on Mars. You've got the Hellas impact basin, full of cloud. That's why it's always so bright. You've got the polar cap up here, and the black mark that's left as the seasons change and the ice cap retreats. It leaves that black sort of ring around. So I've seen, features on Mars firsthand. But as you can see, I'm not very good at sketching. And so what I'm actually using now is a high-speed camera. Now I took that picture of Jupiter at the top with that little 6-inch Max Utov telescope you saw earlier. And just to remind yourself then, so that was a 6-inch telescope, and there are features inside the great red spot on Jupiter. Now that is a pretty hard visual challenge with a big telescope under, good seeing. And there it was in Milton Keynes in the garden, capturing those sort of details. And the second picture down here is one we'll come back onto later, but this is one I'm getting now with the big telescope in the observatory of Mars, and that was actually taken last night, and it looked very hazy, but Mars was just visible through the clouds, so I went out and had a look. So what I'm going to do then is talk about how I go about capturing observations like this and capturing all that fine detail. And so if you can compare the image, the sketch I showed you before with this, obviously we're recording far, far more detail than is visible to the eye in the camera, sorry, to the eye in the notebook. Being able to capture it with the camera and process it actually does put out a lot more detail. So of course, when we think of deep sky images, what they're trying to do is capture many, many long duration exposures of what are quite faint objects. So that's the picture you saw earlier of the Andromeda Galaxy. That'll be multiple hours at multiple filters, and then they'll be stacked together. So what we're going to do actually when we image the planets is we go for the opposite. Our targets are small and bright, so we want to use high resolution imagery and techniques to do that. So how are we going to do that? Well, here is a video taken a few over the last few months. I'm going to just start this going. So this is Mars in good seeing, and sorry for the pixelation that's coming across there. What I'm hoping you can see on your screens, and there's some wind just moving the telescope around here, is you can see down at the bottom left, down at the sort of 7 o'clock position, there's a little white circle. That's the Mars, that's the south polar cap. There's a band here across the southern hemisphere, and there's some features there. It's quite hard. Your eye actually becomes quite good at picking out some of these details. Your eye-brain combination can sort of pick out these faint details despite the effects of the seeing. So the atmosphere is introducing these effects. So think about the lights coming off the sun, travels out to Mars in this case, hits the surface of Mars, comes back. And that last milliseconds it hits the layers of the atmosphere is when all this turbulence is introduced, and it breaks up that wavefront. So, and this is the feature that we call seeing. So this was taken under relatively good seeing, and this is the, you can see some of those features there quite happily. Now this is what happens when we have bad seeing, and it's almost hard to work out if Mars is round. It looks like you're looking through water or something like that, looking at a rock in the river. It's really hard to see anything. You can just about make out the south polar cap there. So certainly comparing the bad seeing and the good seeing. So the atmosphere for amateur astronomers trying to do high resolution imaging is the problem we have. Which is why professional astronomers spend so much money building observatories on top of mountains and putting satellites and telescopes up into space. And it's quite interesting. So pen and pencil technique, up until the 90s, 2000s, you would get far better results visually observing. A skilled visual observer could pick out more detail than could be picked out by certainly film photography, because the long duration, you know, the second or two it took to take a picture, even with these relatively good seeing, would be enough just to blur out those detail. So the atmosphere, while this is very useful for life, we can't deny that, it's not so useful for doing astronomy. And I'm now trying to move across the slides, but it's not letting me. Let's pause those. Next slide. So atmosphere distorts the image. So when we go out and look at the planets, it benefits from being high in the sky. And so by that I mean is best time to observe Mars is when it's on the meridian, or Jupiter is best times when it's on the meridian, when it's due south. And also we've noticed, being up in the UK for the last few years, that the planets have really been skirting down by the horizon. So people down in France, Italy, you know, down in Florida, are getting much better views than us, simply because the planets are much higher up in the sky. And the other thing that makes a difference as well is the local climate. Having a stable high pressure system actually reveals far better seeing than a turbulent, stormy, windy night. So we can't really do much about the atmosphere and the effect that has, other than try and just pick those good conditions when they're allowed. But the one thing we can control is the local environment. So the one thing I found very useful is certainly when I had that little telescope up in Milton Keynes, I didn't have an observatory in the garden, obviously. And so I used to put the telescope out in the car before I wanted to observe. I just put it in the boot of the car, left it there for an hour or two. And the problem is, if I took the telescope out from the house is whatever it is, room temperature 20 degrees or something like 20 degrees Celsius. If you go outside, the ambient air temperature could be whatever, 0 degrees Celsius. And all that thermal heat would rise. You'd get this heat plume coming up off the mirror, off the optics, and that would be enough to distort the image. Likewise, if you observe over rooftops, they've all been heating up in the sun during the day, and at night they're cooling down. And again, that's enough, that heat haze rising, even just a few degrees difference is enough to distort that. And I always used to remember it very frustrating, because it used to, as Mars or Jupiter, whenever I was observing them, would slowly move across the sky. Whenever they went past someone's chimney or the vent from their boiler, you could see for about half an hour or something. It just wasn't any point observing because of that, those atmospheric effects. So I recorded this video earlier. And what I've done is I've got Alpha Aries, Alpha Arietis, Hamel, and I've defocused it on the camera. And what I'm going to do is just show you the effect of just a few degrees of body heat does on the stellar image. So the star's defocused, you can see the defocused star is there. And what I'm going to do is I walk around to the front of the telescope, and I'm literally just going to wave my hand in front of the stellar disk, this defocused disk. And what you'll see is that the disk starts to break up, and that is from the heat from my hand. Just doing, so if I hit play now, you see the rings of the star. I walk in, and there's the shadow of my hand down the bottom. And the star's all broken up. Take my hand away, and it comes back. I'll put my hand back in front again, wave it around, but you can see that disk of light has started to break up, and that is literally the heat from my hand. So I'll play that again. So the advice here is to make sure you stand sort of behind the telescope. So when I'm looking at the Mars is in the south, I'm standing at the other end, I'm at the eyepiece end. So I don't want to be near the telescope opening. You've got body heat, you'll have heat from the laptop, and you can really see the effect there. The shadow of my hand there as I wave it in front completely destroys that stellar image. And imagine what it's like if you're looking through, you know, the heat exhaust of someone's boiler flue or something like that. So make sure you yourself are at the other end, not the open end, and say, if you can, I mean, there's not much you can do about it if you observe over rooftops, that's in the garden, but it does make a real difference to the image quality. So the moment we're trying to do then, so we've got the atmosphere jumping all around, we've got the local environment jumping us all around as well. So to capture these high resolution images, then we're going to use random moments of clarity. We're going to rely on luck, that's what it's called, lucky imaging, to produce a high resolution image. So we put a high speed camera in the focuser, and we're trying to capture many short exposures. And we'll use free software downloadable off the internet called Fire Capture. That captures the videos. Auto Stack It will say, well, these are the sharpest and these are rubbish, and we'll reject the rubbish ones and we'll stack the sharp ones one on top of the other. And Registacks will then apply filters that then sharpen and bring out all that fine detail. And if we capture a number of those, we can then stack those together and sharpen them some more in WinDupos. And then I touch them up in the end with Photoshop and add the labels. And I say this is why professional observers, professional astronomers have their facilities up on mountains or up in space. So I've just run through this again. This is the process we're going to follow. We're going to capture sharp details, we need short exposures. If we take long exposures, the image is all blurry as the atmosphere smears it around. But if we take short exposures, they're noisy, there's too much granularity. So we're going to stack lots and lots of short, sharp exposures, one on top of the other. And that noise, that electronic noise, will average out and the signals will stack up. So let's jump ourselves all the way down to Tenerife. Here's a telescope I had set up on Mount Tidy. I've got the telescope there with the camera, and I've got a mount that's tracking the stars there. And although you can do imaging with a non-tracking, Dobsonian telescope, my strong recommendation is if you have tracking, it just makes life so much easier. You want high resolution, high powered imaging, and if the moon or the planets or whatever is whizzing across the field of view as the Earth rotates, it's just an extra thing. So I'm not saying you can't do it, but it does make so much easier if you've got tracking. Obviously, you don't need GoTo because the Mars and Jupiter and Saturn are easily to find and put them in the crosshairs. So there's the telescope set up on the mount. We're tracking away, and I've got my laptop. We had to use put our laptops in these cardboard boxes so we didn't affect. You can just see up here, for example, in the background, there were other domes and observatories alongside. So we had to have all our lights shielded. So we had to put the laptops, had to have red screens and be dimmed and be inside cardboard boxes so that we could see the screen, but they didn't shine out across the place. So now I'm going to talk through how I go about we've got all the kits set up, and now we're going to start capturing some images. So I use Fire Capture. Again, it's a free bit of software to capture the video files. So it's free to download, and this is going to control the camera and save the footage onto the laptop. And you can see there we've got Mars, we can see the polar ice cap up here. So although the picture is in black and white, we are actually recording color data, and because of that high speed frame rate, to save on the processing power, that color data is in there, but for simplicity, Fire Capture just isn't showing it, so that you can still process it and crunch it up in real time. So what I'm doing here, I'm capturing 150 frames a second, and I am going to, and I can't remember what to do these for, 3 minutes. I've got a 3-minute exposure, 3 minutes of video at 150 frames a second. So I'm capturing something like, I think it's 28,000 frames or whatever that mass works out to. And from that, we will then extract those sharpest of the thousands and thousands and thousands of video frames that we're doing. I've set the histogram up to about 80%, so I don't want to be up to the right. Otherwise, we'll start overexposing, we'll saturate the pixels, but of course, you don't want it too dark either. So about 70 or 80% tends to be, I find, about right. And to do that, then I've adjusted the gain down a bit, and the exposure is very short as well, so 5 milliseconds exposure. The other thing I do as well in fire capture is I set it up so that it's encoding in universal time, and the date and time you can see here is in the wind due-post. In the settings you can do this, and I'll come on back to that, why that's important later. So on a clear night, I might be capturing 10, 20 of these video files, and from those I'll pick the sharpest ones. So make sure you've got a big hard drive. It hoovers up data, even when you have a region of interest like this, where you're deliberately only recording a small part of the video. And the other thing I found very useful as well is using this auto run feature that fire capture has. And you can literally just leave it, takes picture after picture after picture after picture. So you don't have to worry about that. The other point to remember as well is why I'm limiting the video captures to 3 minutes is because Mars is rotating. So if I left this just tracking indefinitely, Mars will rotate over time. And those images, those fine details that we want to capture will all blur away as Mars rotates slowly underneath us. So we capture our video files, and the next day I will process them. This is a program called AutoStackit. One of the annoying things about astronomy for free software is that it's all in different packages. It doesn't exist as a unified bit of software. So you have to download all these different types. And this is a Dutch software people, astronomers who are software people. And they've made this program that takes those video files and it sorts the frames into the sharpest order. So you load a video file in and it says this frame's the sharpest and this is the blurriest, and it puts them all in order. And the clever thing it then does is it breaks the image up into all these little squares, and then it says, right, in all that frames, that is the sharpest little square, so I'll pick that, and that's the sharpest little square, and that's the little, and it merges all those together a bit like a mosaic and puts them all back together again. So it's quite a clever little processing package. So I load them all up, go make a cup of tea and come back about an hour later, and it's then put them all together. And you can see here, I've told them to stack. So what have we got here? 27,376 frames in that video file. And I'm going to tell it to stack 15% of that. So what's that? It's a few seconds of video at the very most. And of those, that will be the very sharpest ones. So having a look at that then, so this is the sharpest video frame of all those, and you see the color data has come back now. That is the sharpest video frame, and it was number 7,768. So of all those video frames, 7,768 was the sharpest, and that's it there. But you can see you can't process this very well because it's very peppery. It's got this very grainy texture. It's a very short duration exposure. And that's the electronic noise from the camera. It's a bit like when you use your own, you know, the phone on your camera at night. It doesn't produce that quality picture because of that sort of electronic noise. So what we need to do then is stack them all together, and that's the result you get. Then we load them up into this program called Registax. And the good thing about Registax does is that it has these things called sliders, these things you can put across, and that allows you to sharpen the image. So this is that 15% of the 15% of that 27,000 stacked one on top of the other. And again, you just lost that peppery sort of grainy texture, but there really isn't a lot of detail still visible. You can just about see the South Polar Cap, so it looks a bit like the video I showed earlier, right back at the beginning. But what I'm going to do is I'm going to slide a slider across to the right, and all the detail suddenly becomes visible. And I find this absolutely amazing that just with free software downloaded off the internet, you can turn that blurry video into stuff where we're seeing stuff that's only a few hundred kilometers across on Mars. This is Solus Lacus. It's called the Eye of Mars. It's a bit like an eye. And we also have some volcanoes here as well. This is the Tharsis volcanoes here, and Olympus Mons is just there. And you know, this is with an amateur telescope in the garden in Salisbury, and there are volcanoes on Mars that we can image and detect now. And these features here, there's the South Polar Cap, and there's a little bit of ice that's been left behind as the South Polar Cap has melted, as spring has turned into summer. And that's all just from following that in. So taking that blurry video Jump to the next slide. So what did we do then? We took that's the first frame of the video, and you can see there's not an awful lot of detail visible. That's the sharpest frame of the video. So again, there's a little bit more detail visible here, but it's got this awful peppery, granular texture. So we stacked the sharpest frames together. But again, there's still not a lot of detail visible, but all that data is in there. It's all in that stuff. And using those special sliders reveals all this fantastic imagery. And I find that absolutely amazing. It's all in there, but it's by following that process and coming out. You can start to see there's some sort of haze on this limb as well, of the morning clouds as well as Mars is rotating, and the North Polar Hood up here. And it's all, you know, amateur telescope, you know, resolving surface details on Mars, resolving craters. So I tell people at work, they said, oh, did you get that much at the weekend? And I say, yeah, I managed to photograph some volcanoes on another planet from my garden. So it's not a bad hobby to be involved with. And looking at that picture at the bottom right, remember we said earlier when we look at the moon that the view is very similar to a naked eye view of the moon. And it does, isn't it? Because that's roughly, you know, maybe a pair of binoculars or a telephoto lens. That's the view you would get of the moon, and that's what we get to see on the planets as well. That same sort of angular size. So we mentioned earlier that obviously the planets are rotating over time, and this was taken earlier in September. So we've got an hour or nearly an hour of Mars rotating. So if you look up here, the first image, you've got the eye of Mars, Solus Lacus is quite in, but on the very last image, it's quite close to the limb. And that's because Mars has rotated, and each of these is 5 minutes apart as Mars has slowly rotated underneath us. So the last thing we could do, we can't stack these all together because, of course, they're not the same images. They're all moving around. So the last bit of software we use is WinDupos, which again is a free bit of software. You download it, and what it does is it tells it to measure these images. And if you remember earlier, I said make sure you save them in the WinDupos format. And again, there's a button in the settings that allows you to do that. And that brings out, you don't then have to type in the date, the time, the location, etc. It automatically loads that in from the file name. And you say, read this, you line up this circle with Mars with the north-south line, and it then converts all that data, and then you can stack them all together, this little list here, and it stacks all those images, but it takes into account, if you look at that little circle there, the rotation of the planet in the meantime. So if we've stacked it again, that means we can process a little bit more of the signal out here. I can't remember which date that was the 20th of September. So earlier this month. But again, you got some little clouds and striations in the North Polar Cap. Sorry, the North Polar Hood here on the north surface of Mars. And I just think, wow, this is amazing. You know, this amateur telescope in the garden, and here we are picking out details on the clouds over the North Pole of Mars. So that's the process we follow to capturing all the capturing those video files and turning the sharpest frames into the best single strip image. So the other thing we need to mention as well is how bad the atmosphere is in terms of the seeing, but it's also, despite its clear benefits to life, the atmosphere also acts a bit like a prism. So as stars, or in this case the planets, get lower in the sky, the light gets dispersed. So earlier this year in May, Venus was putting on a good show, as was Mercury. And I took the little 6-inch telescope outside and had a good view of the western horizon. And the image on the right shows Mercury. And I had to use this thing called an atmospheric dispersion corrector because the image on the left is out without it. And you can see the effect this red, green, and blue has, and that is literally the atmosphere. Mercury was only a few degrees above the horizon when I took this, and it literally is acting like a prism. So I bought this atmospheric dispersion corrector, which is basically this device, and it has prisms inside, 2 little prisms attached to these levers, and you twiddle the levers and in a particular way, following the instructions, and it counteracts the atmospheric dispersion and realigns the light back up. So you can see here, Mercury is pretty unobservable. You can't see anything in that. It's just a smear of light from red to blue. But by putting the atmospheric dispersion corrector in, there it is, you realign all that light back in. It's still a pretty low, the Mercury is very low in the sky, so it's not a tremendous amount of detail visible, but at least it is observable, which it certainly wasn't without that device. So the atmosphere really does sort of hamper our amateur astronomy efforts. And the other key point to mention is that, of course, you use this whether you're visually observing or whether you're using the camera. That dispersion effect is still there, whether you're observing with the eye or whether you're observing with the camera. So an atmospheric dispersion corrector is thoroughly recommended, particularly with Jupiter and Saturn being so low at the moment. Or as I said to my wife, we could always move to the Canaries or the Caribbean, and when the planets would be much higher in the sky. But I'm afraid we're still stuck in Salisbury, so it's much cheaper for me to go and buy the atmospheric dispersion corrector. So talking of equipment, then, we talked a lot through the process. Let's have a quick look at the telescope in the observatory then. So this is the picture that my wife calls the just one more thing. So I borrowed originally a camera from a friend of mine, and quite enjoyed using that on the telescope up in Milton Keynes when I was working up there. So I got permission to go and buy my own camera, which is this one here, made by a company called ZWO, a color camera. And so I got permission to buy the camera. And the problem is the camera chip, the electronics inside it, are quite sensitive to the infrared light, the far part of the red. So you then have to go and buy another infrared filter to cut that off, and it stops the smearing of the light. Gives you a much cleaner image if you have that infrared filter in there. So that's to go and buy an infrared filter. And the image, even though this telescope is a f10 focal ratio, as we talked about earlier, those planets are very small. So I had to go and buy a Barlow, which you've got in here as well, to magnify the image of the telescope. So my wife said, yes, you can buy the camera and you can buy the filter, and then we'll go and buy a Barlow as well. Now, the telescope here focuses by moving the primary mirror up and down inside the tube, so it's a bit clunky and it slops around a little bit. So I then said, well, I'm finding it really hard to get a good focus, and focus is so important when you're trying to do this high resolution imaging. So I then bought a Crayford focuser that then screws onto the back of it and has these wonderful little slow motion controls on here. So I've now got a very nice high magnification image. I can now focus. But the problem is with doing that is that because every time you touch the telescope, it jumps around all over the place. You've got this high magnification device, and every time you touch the focusing wheel, you now have to, it jumps all over the place. So I said, well, I really need to buy a motorized focuser. So I bought a second-hand Skywatch autofocuser as well, and I bolted this onto the side here, and that means I can now, with hands-free focus, I just twiddle the little hand control that's at the end of this cable. So I bought a camera, a filter, the Barlow, the Crayford focuser, and the motorized focus as well. And all I wanted to do a few months ago is go and buy that camera before that. And then, of course, we mentioned earlier how the planets are quite small. And we're trying to line them up on this chip here. And we're already using a Barlow lens, so we're already at quite a high magnification. So it was really hard trying to line up the Jupiter or line up Mars on the crosshairs in the finder scope, get them into the eyepiece, swap the eyepiece over for the camera, and you find it wasn't there. So I then said, well, I really could do with buying one of these things called a flip mirror, which is this big box-shaped thing here. And what it does has a mirror in there, and the light comes down the optical path, and you put the mirror in the way, and it focuses up, reflects it up here to the eyepiece. But when you want to, it then has a little switch on the side you lift out the way, and the light can then travel down here, so the mirror flips out of the way. So I only went out to go and buy a camera, and I've now got 7 or 8 other things as well, all hanging off the back of the telescope as well. And then, of course, you need the atmospheric dispersion corrector and filter, which we talked about earlier. That realigning the light back in. So my point here is that you do need it is recommended some of this additional stuff as well to make it easier. You don't really need, apart from the camera obviously, any of it to take pictures. And I upgraded over a period of months just as pay packets were allowed. But my wife calls this just get one more thing, because she said, you only went to go and buy a camera 6 months ago, and now we bought another thing and another thing and another thing. And I do think back to observing with just a notebook and a pencil, and it just seems to be an awful lot easier to just go out there and just relax with the human eye, as well as having that aesthetic effect, as well as just being able to enjoy looking at the planets. And that's why I quite enjoy. So sometimes I'll capture 5 or 6 video files on the laptop, and then I'll flip the mirror back down, and I'll just take 15-20 minutes, and I'll just enjoy the view through the eyepiece as well. And it's nice being able to have that effect both at the same time. So let's go and have a quick tour of the solar system. Then let's go and have a quick tour of the planets. So we mentioned earlier that Mercury is quite a small planet. It's the closest to the sun. It's a bit bigger than the moon, but much smaller than the Earth. So it's quite a hard planet to image because it simply is so small. And I don't really have a very good image of Mercury. And this is one I took when we were down on Tenerife a couple of years ago. And I thought, oh yes, I do have a good image. And this was the Mercury transit in 2016. And I hope that's coming through okay, this large red thing. But it was a wonderful view because you have Mercury moving across the face of the sun past this little solar prominence here. And if you remember that picture we had earlier of the moon and Saturn, it just gives you an idea of how small Mercury is. And this is at its largest because it's obviously between the the sun and the Earth. So it's at its closest point in its orbit to us as well. So Mercury is absolutely tiny. I do like that picture with the prominence alongside it. Here was Venus, taken earlier this year. And we had this wonderful apparition of Venus in the sort of late winter and sort of early spring. And Venus, as it undertook the Earth on the inside, was, we got to see more and more and more of the dark side. And of course, as it got closer and closer to the Earth, it got much bigger as well. So a really lovely picture. I quite enjoyed that. And that was published in Astronomy Now. And that was great fun capturing that as the spring weather approached. And I really struggled with Mars up until this year, actually, because Mars has been so low to observe. It's been really hard to capture, and these are the best images I've caught in there. And then we went out in 2018 when the last Mars opposition to try and capture it. And we had this huge global dust storm came across, and it washed out all the features. You can just see some surface markings coming through there. And with an infrared filter, the heat, the glow is a bit more visible because the infrared was penetrating through the dust layers slightly better. And while we were there, actually, we were there for a week, and the last couple of days, when the Saharan dust storms blew across the Canaries. So I've actually observed Mars through a global dust storm, through a dust storm on the Earth as well. But this year, this apparition has been absolutely wonderful. And say capturing features like Martian volcanoes. I can't get over this. We're photographing Martian volcanoes from my garden in England is absolutely wonderful. And then earlier this month as well, one of the Martian volcanoes, Tharsis volcanoes, is Arsia Mons. And then in the Martian late evening, you had this cloud formed on the surface, blown up by the winds, and then it left that trail going across there as the wind blew it across. So really wonderful, to be able to photograph clouds forming as the winds are blown over a volcano on Mars from my garden. It's a tremendous thrill. You can see Olympus Mons up there as well, the highest volcano in the solar system. And Jupiter is a wonderful planet to observe as well. You've got the moons. We talked about the moons earlier and capturing those movements as they orbit around Jupiter. And you can see the storm clouds there as we did. But what I'm going to do is I'm going to show you a little video. I took this a few years ago. It was like 2015. And I've got the telescope up and running, and there's Jupiter. And you can just see the great red spot in there. And what we're going to do is I'm going to press play, and we're doing some wide field, or relatively wide field imaging of Jupiter and the two moons. I think they're Io and Ganymede. And then I quickly put a Barlow lens in, and then we'll capture those. So I'll press play. So there's the great red spot on Jupiter. Jupiter will start, these pictures are taken 5 minutes apart. So Jupiter's slowly rotating, and we put the Barlow lens in. And then the two moons actually occult each other. One passes over the top of the other. And so I've seen this real time from the garden. And I'll pause it just as we get to the end, because I didn't realize this until afterwards. There we go. Oh, missed it. Let's go back up, press play again, slide across to the end, pause. But you can see that Io, the one on the left, is smaller than Ganymede, which is the biggest moon of Jupiter. And again, this is with an amateur telescope, but you can see the relative size difference there of the two moons. And this is how the people, you know, the Damien Peaches of the world resolve surface details on the moons of Jupiter with an amateur telescope. So Saturn, beautiful object, always catches everyone's, you know, all the oohs and ahs when you look at Saturn through a telescope. It's always such a beautiful sight. And you have these wonderful moons going around as well, and the ring system as well, always a glorious sight. But Saturn's strange. You've got this dynamic nature on Jupiter with the moons whizzing around and the storm clouds, and you've got features on Mars as Mars rotates in front of us. But Saturn doesn't really do anything. It's one of these things that's very beautiful to look at. But it doesn't really have much happening on its surface. So I always like looking at Saturn, but I sort of take a picture and then sort of leave Saturn for a bit. As it say, it's not very much happens on its surface layers, on those atmospheric layers. But this year, date for the diary then at Christmas, December the 21st, Jupiter and Saturn are going to be the evening star. And this is from Sky Safari, the planetarium software I use. But with a low power eyepiece, you're going to have this view of Jupiter and Saturn together, plus all the moons. So I'm really looking forward to this. So December the 21st, apart from being my grandfather's birthday, I will be outside photographing Jupiter and Saturn. So goodness knows what the astrologers are going to make of it, this you know, Jupiter and Saturn, the evening star, coming together at Christmas. So one for your diary there to catch in a few months. So hopefully this is going to come through, because it's looking awful on my screen as we look through Zoom, but these are some shots of Uranus. And I've also managed to capture 4 of the Uranian moons. Now the moons of Uranus are named after characters from Shakespeare. And we had a good run of weather last year. And I've realized I've actually used the wrong date there, because that should be 2019. So what I'm going to do is I'm going to press play. And you should be able to see, hopefully, if it comes through okay, the moon's going round Uranus as seen through the telescope. And you can see the little moons on the inside whizzing around, while Oberon and Titania take slightly longer to go round. So when we look at that picture of Mercury and the going in front of the sun, if you remember, the light from the sun only takes 8 minutes to reach the Earth. The light as we get out to Uranus and Neptune, I think it's 2.5 hours now. It takes the light to get from Uranus back to the Earth, and 4 hours from Neptune. So we really are right out in the far end of the solar system, 8 minutes now to 4 hours. Just gives you an idea of how much further out into the solar system we are. So here's Neptune, the last planet of the solar system. And Neptune has captured a moon, Triton, which is one of the Kuiper Belt objects, or believed to be one of the Kuiper Belt objects. And Neptune's tiny, 2 arc seconds in diameter, with little Triton alongside it. And luckily, there was a field star in a way. This is just a background star in the sky. And again, in the same time period in November last year, I would go outside and photograph and then use the star as a reference. So what we're going to do is press play. And you'll see Neptune moving towards that star, and Triton as it goes in its orbit as well, every 6 days, rotating as well. So as you can see, even right out at the edge of the solar system, you still have these dynamic worlds, and they're visible through our telescopes, through our amateur telescopes. Now, I took this picture last night. It was a very hazy night here in Salisbury, and I finished processing the joys of working from home. I quickly finished processing this while we had our team conference call this morning, and I sent it to the BAA, and the director of the BAA, the Mars section director, Richard McKim, wrote back to say, I caught the height, which I hadn't realized this, as I'm still getting up to this. This is a crater on Mars. This is the Huygens crater at the foot of Syrtis Major. So we're actually capturing, again, with an amateur telescope, a crater on Mars. So, you know, you can actually resolve real worlds, you know, with a high-speed camera. So I think the Huygens crater, when I looked it up, is 300 miles across, 450 kilometers, but it's 400 kilometers across, but 62.5 million kilometers away. And yet it's visible following this high speed, the lucky imaging techniques. We can start resolving these details on other worlds. So that's all from me. I've hopefully given you a good talk about how I go through observing the planets. We've used binoculars to make sketches and take simple photographs. We've talked through the equipment you need for planetary observing. We've talked through the effects of seeing and atmospheric dispersion. And we've gone through the process to then do high resolution imaging and finish with some time-lapse imagery as well. So thank you for having me along tonight. And if there are any questions, I'll be pleased to answer them.
Thank you very much, Mark. That was wonderful. And one of the things that I appreciated the most is I've been to a lot of talks, and usually the photos are from last year. But it's great to see lots of current stuff going on and stuff that we can go out tonight to go and see. So on those images you've got of Mars. Yeah, and I'm sorry your meeting suffered without you whilst you were pressing buttons and perhaps listening in today. But what questions have you got for Mark, everyone? Hopefully all your mics, it's a matter of just unmuting yourself.
Can I have one?
I mean, go for it, Charles.
Mark, it was a great talk. It really was. I'm a visual observer. I don't do imaging, but I can certainly see why you can see the advantage of doing so. But clearly you're interested in observing in different kinds of ways. And one thing that interests me is observing in daytime and seeing how many planets you can see in daytime. Now, clearly with Venus it's fairly easy, and Mercury also quite feasible. And I once, about 15 years ago, also managed to see Jupiter in daytime. It was quite well placed, the conditions were right, it was a very clear sky, it's quite close to Venus as well. But I sort of infer from the picture you showed of the moon occulting Mars from Tenerife fairly early on in your talk, and that looked like a sort of early dawn time. So I sort of infer you could probably actually observe Mars as well in daytime. Was that correct?
Yeah, it was dawn. It was about 6, 7 in the morning, something like that. I'd have to look at my notes. So yeah, it was definitely a blue sky.
Yeah,
and you could definitely walk around without bumping into things. You probably could have read a book or something outside those sort of sky conditions.
Yeah.
But I've observed Venus, certainly when we had that evening apparition of Venus, and you've got the picture on the right-hand side of the screen. Yeah. So it's still daylight. Yeah. Some, was it April, May time, so that, starting the long days. Yeah. But you can see the conditions there to be able to see Venus. But Venus is when it's far from it's so bright, isn't it?
It's easy. It is.
If you know where to look, that's the key to it.
Yes.
But I've really struggled with Jupiter because it's just been so low for the last good 4 or 5 years. And you can see in the background there, we've got a few trees around us. So I haven't done as much Jupiter observing as I would like. But there's no reason why you can't do it, of course, is there? As long as you've got the telescope lined up and you can put it out.
What I'd say is the one time I did it, the conditions were very good. I mean, it was about 15 years ago. Jupiter's higher. The sky was, the transparency was very good. And the actual, you could tell the actual sort of surface brightness of the Jupiter image against surface brightness of the sky was quite comparable. So it's a ghostly figure you could just about see emerging from the sky. And it's actually easier to see in binoculars, coming back to your point, than it was in the telescope.
Oh, okay. That lower magnification.
Yeah, indeed. So anyway, thank you. But it's a great talk. Really enjoyed it.
So when I was observing, so I sometimes gone and had a look at Venus during the day. And then you think, wow, okay, I'll have a swing across to try and find Mercury, but I've never managed to find Mercury in the daytime.
Sorry, Mark, do you mind dropping your microphone a little?
Sorry.
There you go.
Can you hear me okay?
Yeah.
So being able to find Mercury was absolutely terrifying because the sun's so close.
Yeah.
You daren't look through the finder scope, and I'm trying. I tried a few times, failed, but I think I was probably being a bit too nervous. Well, maybe I wasn't being too nervous, but I was just very conscious that if I look through the little flip mirror or I look through the finder scope, that could be could be a bad move. So I sort of gave up and left it.
Well, what I've done, I mean, I had done it, but what you had to do is to move the telescope. So that if it's sort of on a flexible tripod, so that it's actually in the shade from the sun. So you can place yourself, but so you cannot make a mistake of looking at the sun.
Yes, maybe that's the way to do it.
It's 20 odd degrees away. You can do it fairly easily in the right kind of pressure. I didn't do this time round, but it is doable.
Yes, maybe I should be using the smaller scope rather than the bigger scope that's fixed.
Sure. Yeah.
Any other questions? I've got one, Mark. You've got loads of stuff going out the back of the telescope. Is it bend? Does that change the optical path?
Does it suffer from droop? No.
Yes.
So when yes, you're absolutely right. So don't forget, of course, it's quite lightweight stuff. So it's not like a big heavy eyepiece. So some of my eyepieces weigh more than that stuff at the end. But the focuser can rotate. There's a little screw. I don't know if you can see if the mouse symbol's coming up. There's a little screw there, so you can rotate the focuser to whatever angle you look. And what I have done sometimes is forgetting to tighten that up, and the whole thing's counted off at an angle. But no, tightening up all the screws. It seems to be pretty robust, and I've collimated it with it like that as well. So I guess maybe that's counted it all out.
What other questions have we got? Does everyone want to have a go? Go and get yourself a little camera and
do it quick before Mars disappears.
I was actually most because I've taken a few photos of Uranus, but I've never really thought of doing a time lapse and trying to sort of see the moons as well.
The hardest thing was trying to get I've tried several times to do that, but the hardest thing has been, of course, trying to have consecutive clear nights. So I sometimes have 2, maybe 3 clear nights, but that was actually sort of 7 or 8 with a couple of cloud nights in the middle. So that's the best I've done. I remember when I was in Florida at the Star Party, there was a guy there I was camped next to, and he was from Colorado. And he said, I do astronomy on Tuesdays and Sundays. And he said, well, we get 330 clear nights a year. And he says, and Wednesday was bridge night, and Friday they did family stuff, and Saturday they'd be out during the day. So he did his astronomy on Tuesdays and Saturdays. And he would prioritize if there's. I thought, because what I find is that you get a clear night, you think, I'm a bit tired from work or family stuff's on. But then if you don't want to waste it, so you go out anyway and you're tired and stuff. But then if you don't take advantage of those clear nights, it might be another week or so till it's clear again. So yeah, moving to Colorado or Florida, I think would be rather pleasant.
I'm not sure my wife will let me do that.
Well, one more for me, maybe. Have you tried trying to find detail on Uranus? Because one of our members, now not active with us, reckons you can.
Yeah, so you can sometimes see some the what do you call it, the sort of global shading, if you know what I mean. So the poles, or well, Uranus has fallen over, but the on the limb it's a bit darker than on what would be the equator if it wasn't on its side. So yeah, it's pretty subtle. I'm not too sure I can claim to have seen it, but I'm sure you could have. One could have.
Well, I mean, in terms of your image processing, have you tried to
No,
actually...
so I've got some pictures, some higher resolution pictures that I've got, but it really is just either a green disc or an even smaller blue disc for Neptune. But no, I certainly haven't seen any sort of banding or limb darkening or anything like that. I'm sorry, you can see the limb darkening, but you certainly can't see any banding, or certainly in my experience, you can't see any.
And your
sorry?
Your sliders don't do it for you.
No, well, they hide it, but the other thing as well is because you want to take a number of pictures, capture a number of frames, but because Uranus and Neptune are so faint or relatively faint, is even just trying to capture 1,000 frames might be sort of 10 minutes of process. Maybe it's my attention span. I thought, well, I can't sit here for 10 minutes, so I normally just capture a few hundred and then try and stack those.
So presumably means each frame, therefore, needs to be a longer period, and therefore you've got more atmospheric distortion.
Yeah, so that's the constant thing.
So,
you've got this constant trade-off between if you boost the gain, then your exposures are shorter. You boost. It's a bit like boosting the ISO on a camera or the the electronic amplification. But then, of course, you're also amplifying the noise, so you therefore need more of them to cancel out the noise. So it always seems to be this constant trade-off as well. But yes, one of the things I do want to say, I've got a list of things I do want to do. So one is when Jupiter's higher in the sky, is try and do a whole rotation of Jupiter. So Jupiter rotates every 10 hours. So if it's in the winter sky where it starts for sort of 6 o'clock to 7 or 8 in the morning, that's easy enough time to do it, to catch it on one horizon, capture on the other. Do a full 10-hour rotation in one go.
And it will be if it's high in the sky. It'll be winter,
yes.
Isn't it?
So maybe in a few years' time, when Jupiter starts climbing back into the northern sky, that's what I want to do.
Planning ahead.
Yes, always got to have your dreams.
Yeah. What are you going to do to fill your time in between, though? Because that's not going to happen for a while, is it?
Yeah. Well, so the moon's always around, and Mars is pretty good, and Mars will hang around. Although it won't be so big, it'll still hang around for months. Keep our fingers crossed for another bright comet.
Yeah.
Uranus and Neptune, we just talked about those as well, so they'll be around as well. Venus will come. I've been watching Venus in the morning sky when I've been getting up early to look at Mars, and of course that'll then come back around into the evening sky again as well. And that's quite a thrill, looking at Venus through that bright crescent and thinking, whoa, there's now evidence of bacteria in the atmosphere of Venus. So that's quite an exciting thing to be looking back at.
Have you got any tips for that 21st of December? Because they're going to be quite low, aren't they, Jupiter and Saturn?
Yeah, that's the problem, isn't it? They're going to be quite low on the sky. So you want to go, it's going to be setting in the west, isn't it? So it's going to be you'll need a good western horizon. And fingers crossed for the weather, because, of course, that time of year, the weather can be pretty bad. So get a decent western horizon. Have a nice low power eyepiece or a wide angle camera lens. You capture the two together, with all the scenery as well, and then put a high power eyepiece in, and you can get all the things as well. And so what I didn't mention earlier is that when you're capturing the moon, so you've got those picture of the at the bottom of the screen there, of course, they're composite images, so the moons are much fainter than the planets themselves. So I've often taken a picture of Jupiter or Saturn or whatever it is, and then of course you have to then take another picture, but with a longer exposure to then make the moons come out. And then, of course, in Photoshop, you can blend the two together to do that. Is there time to I'll just go back to this, press escape? Didn't I put it in here? Bear with me. New images, Mars. So the other night, the seeing was absolutely atrocious. And everything was jumping all over the place. So share screen, and I want to share. Where's it gone? That one. Is that coming through? I don't know why it was. Yeah. I don't know what's happened. It's got two pictures, one on top of the other. But anyway, on my screen, it looks like one picture on top of the other. So what I did there is the scene was awful. It was at 26th of September, so 3 or 4 nights ago. Everything was jumping. But I took 100 photographs of Mars, but I really turned the exposure up, and you can just see in the glare there is Phobos.
Wow.
And that's the moon of Mars. And Deimos was way off to the side, so I looked it up on the planetarium software. But that's a 22-kilometer diameter captured asteroid orbiting Mars 63 million kilometers away. And I photographed it from my garden near Salisbury. And I think, so if the seeing's bad, there's always something else to look at. And maybe one of the things I'd like to do as well is maybe take a picture every 5 or 10 minutes, because Phobos orbits every few hours as it whizzes back and forth. So you can make a little time lapse of Phobos moving over a few hours.
That's really cool. Excellent. So how dark is your skies down in Salisbury?
Well, it's better obviously than living in town. I mean, I was at university in Bath. I can remember Oldfield Park. You could read a newspaper outside at night. With all the street lights and stuff. So we live in a village near Salisbury, so it's not too bad here. I mean, so I could easily see Comet Neowise from the garden. But there's a lot of military installations here. So we've got Porton Down a few miles away. And even though there's only a handful of people working there at the moment, you've got all these car parks that are just lit up even in the middle of the night. You've got the army camps on Salisbury Plain themselves, which a few thousand people working and living on as well. So it sounds quite nice and rural, but it's actually, there's lots of little installations. There's a little group of us actually called Salisbury Plain Observers Group, and we sometimes go up onto some of the car parks on the edge of the military training estates and observe from there as well. Really get away from the street lights. But I don't think there's any way you can really go in England. Cranbourne Chase has become a dark sky where you can really properly get away from light pollution. With work a few years ago, we were very lucky. I was working for an aircraft company, and we did some flight trials out of the White Sands Missile Range in New Mexico. We were at 6,000 feet. I think the nearest street light was something like 40 or 50 miles away, and it was a little farm or something like that. The very large array was sort of in this part of the world because it was quite radio quiet. And the sky there was just unbelievable. It was hard to find the constellations because all the faint stars looked so bright, and you could pick out the zodiacal light in the morning and the evening and stuff. And the problem was, having spent a month working there, and then we flew back to England, is that every other night skies looked absolutely rubbish in comparison. And the problem is, once you've seen it, you can't forget how good it looks.
Excellent. Well, any closing questions that anyone wants to before we close for the evening? No? Well, thank you very much, Mark, for a riveting talk, and it's given me some ideas. Unfortunately, I might have to get my wallet out, but that doesn't happen very often, especially not near pubs. But luckily, we're not going near pubs at the moment. So thank you very much. Good luck with your all your future photos and things, and thank you very much for all your time.
Well, thank you for having me.
Thank you.
Thank you.
So that's it. Thank you very much. The next session is 28th of October with Steve Tonkin, which is his binocular talk, Two Eyes Are Better Than One. And we mentioned Cranbourne Chase there. He's just got a new job. he's the dark sky advisor now for Cranbourne Chase. So he's going to be running around telling people to put their lights out now all across Cranbourne Chase. But Cranbourne Chase also includes that White Sheet Hills site that we go to as well. So it's a big old area. But we might have a few questions for Steve over and above binoculars about what he's going to do to try and darken the skies. Because I know a number of people, well, I think we've all got an interest in darker skies, and Charles especially with the Starlit Skies Alliance that he's part of. So we'll watch this space. Thank you very much, everyone. Have a lovely evening. And with your ideas, just drop us a line and we'll see what we can do. Thank you.
Mark. Thanks,
Good night, everyone.
Thanks, Mark. Thank you.
Good night.
Bye.
Night.
Thank you.
Fascinating.
Thanks, everybody.
Thank
See
you.
you next
Bye.
time.